when Brian said team, that was a little bit of a stretch because my team consists of one person. So, but yeah, officially I'm a team. And my official title is Scenario Creation and Testing Analyst at Safe Software. So I create scenarios, realistic user scenarios, something like people like you do with your data, not like taking an A and getting B, but rather taking a city and adding maybe some real pipes and maybe some real point clouds and doing some stuff that looks good, so that then I can share my results and everyone would like to do something similar with their data. So, so who thinks here that bands are fun? Well, Chris. He does all this job with raster job and point cloud job. He's our main developer in this area. Of course, he's so excited. But of course, I didn't expect that you will be cheering here and jumping. I'm trying to change your opinion with this simple slide. So what did I do here? Can you tell me? I just took 3 raster bands, RG and B, and shuffled them, or wait, 6 combinations, right? And I can be half, or Thanos from the Guardians of the Galaxy, right? It's pretty exciting. Just by changing the order of your bands, you can get something really interesting. And you know, I just thought about that it's not for our eyes, RG and B, it's not how we see them, it's not in equal proportion. Our vision is a little bit extended in green and shorter in red and blue. So by changing the order, you can maybe see more details of something. But of course, there is much more to that. So how it all began, this guy, French person, Gaspard Félix Tournachon, correct me if I'm wrong with that, also known as Nadar, patented the idea in 1856 to take a camera to hot air balloon, fly over Paris and take some pictures, and he did it 2 years later. Unfortunately, those images didn't survive these 160 years, but we have some pictures taken in 1860 in Boston, so that's one of the first aerial or remote sensing pictures. So that's how we began doing remote sensing. But then bands, they start here. Well, the experiments began around the same time when Tournachon took his flights. But, well, this is a picture made by Sergei Prokudin-Gorsky. It's a Russian person who lived in the beginning of the previous century. He traveled around Russia taking pictures, thousands of pictures, with 3 glass filters, blue, red, and green. So you can see those bands on the right, and then combining them together to get, I think these colors are really beautiful. So then people took another step. They'll fly much farther, much higher, and a quiz is coming. Are you ready? So where is this? Who can tell me the geography of this place? Any ideas? Some people probably, know. Some people attended my previous sessions, but if you didn't, then answer, please. No one. It's Black Sea. Pardon? Yeah, Crimea, Turkey. And if he falls down, well, directly probably will be Mediterranean or Israel or maybe Syria or Jordan, somewhere there. So, and it's painted by Alexei Leonov, the guy who first left the spaceship and made a spacewalk in spacesuit. So he was the first one. Apparently he was a good painter. He is a good painter. He's still alive. He's with us. So, well, now we have those satellites in space, and they can take pictures in visible spectral range, but also outside of that. So that's why I'm talking about bands. They deliver their data as raster bands, not combined together into nice pictures, but just separately red, separately green, separately infrared, and a few other bands. So here is an example. That's what we get from Landsat. You can see that it's basically You can see that it goes by wavelength from shorter to longer. And here we have panchromatic bands, which has a higher resolution, and the range is about the same as visible range. So we use this band to increase the resolution of the color bands, which are 30 meters. So by combining them together, you can get some interesting results. So if you combine just RGB, we get traditional what we see images. But if you combine, for example, infrared, red, and green, we get something what you see on the second picture. And can you tell me what is different about pictures made not in a visible spectral range? Water really stands out, right? It's not like on that one. We clearly can see where the ocean and where the land is. So that's an advantage of using different spectral ranges, because, well, everything reflects except black holes. Everything reflects light back and reflects differently depending on what light comes in. And I will be showing an example how that works a little bit later. So this is a workspace that makes all those images. It's not that complicated. It's just, I have to make all the possible combinations. That's that vertical column, what it is. So the important steps are, I'm not going into details of some of them. So radiance and reflectance are important characteristics of the images, and you just get that from metadata, and you better search internet, some papers that explain how it works, then talk to me about that. I'm not a specialist, really. Then you sort and combine your bands in the order that you need, and we did that exercise during our training on Tuesday, where I just asked people to assemble together 3 bands, RGB, and when they did that, some of them got nice-looking pictures, some of them got something really strange, well, unearthly colors. It's that because, well, you saw my face, right? So that's what you can get if you don't sort them properly. So then those bands don't. Those bands usually come with interpretation, so how many bits you have for color, 16-bit interpretation. So you have a range from 0 to 65,000. But the values are actually what comes from Earth, what is reflected back to the sensor. So the values can be in the range from, say, 500 to 2,000. And it means that you see it really, really dark. So, and then you have to apply some multipliers to get it to stretch it to the available range. And here, well, here you have to involve some science and also some judgment and some, your taste. Because, well, we weren't there when the picture was taken, and we don't know exactly how it looks like. And then we all have slightly different eyes. So, but I found that sometimes you have to multiply red, say, by 20, but green only by 18, and blue even by 15, just to get what appears to me looking good. But that may be totally wrong or totally different for a different area on Earth. Then you can punch sharpen, as I said, and maybe then adjust brightness and contrast. So, and that's what you can get an infrared, red and green image. That's what gives back to you. So, or if you zoom closer to one of the areas, and I think it's sometimes really beautiful. So, and useful transformers. So this is my favorite one, raster expression evaluator. Here where you can do math on each pixel. So you can take a pixel value, say 2,000, and you would like to stretch it to that huge range, and you multiply, say, by 20 or 30 or 100. Or you can take some, as I said, from metadata, some attributes from metadata and introduce the correction into those values, like reflectance to radiance to reflectance. Or you can work with 2 bands, and I will be showing that, or with 2 rasters to, well, do punch sharpening, for example. And you also can use conditions here. So if that value is 0, then set it to that. Otherwise, set it to that. That's what this syntax says. And we did that exercise during our training, so people were able to try it. These are like little brothers of that one, of raster expression evaluator. But you see, they're not connected. Parameters are not set. That's mostly because I never use them. But for some people, they might be easier. I don't find that they're easier. And some other useful raster transformers. Band orderers, so you can either sort them with attribute creator and sorter, or just say, I would like to get second, then 0 band, and then third, and they will change the order. Raster resampler, you may need it to bring, for example, for pan sharpening, you have higher resolution and lower resolution image. To combine them together into a single image, you need the same resolution. So you would increase the resolution of your color raster. Band combiner, it's obvious, yeah, we combine them together. Raster interpretation cursor. For example, Sentinel delivers their files, they have interpretation gray 16. Technically, they have the same values as, for example, red or blue, but FME thinks that they're gray, and you won't see them as, well, color bands. So with raster interpretation cursor, you can change basically anything to anything wherever that makes sense. So I can show you that workspace. It's smaller and simpler version. So here I read a few GOT files. And if I have multiple bands, here I just filter them so that I can output them separately, combine them together, green, red, and infrared. Maybe I can run it while I'm talking about it. And then I have my panchromatic band. So here I perform pan sharpening. It's just a few expressions applied to each pixels, which take some information from my monochrome, not monochrome, but grayscale high resolution image, and apply it to the color, or applies colors to that high resolution panchromatic image. So it shouldn't take too long, but I have the output here anyway. Here it is. Yeah, so this is how it looks like. Again, can you see how water stands out? And then we see a lot of red. But if you zoom to Vancouver, you see that it's not that red. It's rather grayish. And why is it so? Because, well, vegetation is very red on these images. And I'm now going to tell you why. And here is another copy of that. So basically, when you have infrared band, you can say how healthy your vegetation is. How does it work? So for photosynthesis, plants need light. And mostly they consume visible rays. The same as what we see, they consume as their food. So they need photons, and they need CO2 to generate organic matter. But you can see here that they consume mostly blue and red, whereas green is not that popular. And that's why we see them green. So do plants love green? No, right? So they reflect it. But here, something strange is happening. So you see that this line just falls, and when we move to infrared, they mostly reflect it. So if red light is consumed, it looks really dark. Nothing gets back to the sensor. If something is reflected, you see it really bright. So if infrared is really bright and red is really dark, then you have healthy vegetation. So, and that's what this formula, this expression calculates. So, and it's as simple as that. But if you are going to make an insurance service or something like that, you better talk not to me again, but to specialists, because it's much more complicated than that if you do it like really seriously. So here's this expression and the results. So the values after that expression go from -1 to 1. 1 means the most healthy vegetation. 0 is probably not vegetation at all. Minus, it's probably water. So, and then I just simply colored that, and we did that exercise again during our training. So people know how to create these color palettes to create that. So in useful transformers here, I used palette adder, palette generator transformer. So and some scary expression, just to impress you. Yes, I think here I have something like 17 closing brackets. And now I can go to that workspace and show how it works. So here, I have this expression, which takes planet imagery, but I don't read it directly from their website. I just download it and work with it here locally. And the expression. And then this is an interesting transformer. I probably should show how it works, because just it is really worth it. So, and probably, no, I will run it. It does not take long, just 22, 23 seconds. Yeah, meanwhile, so these two transformers are available on FME Hub. You can download them and play with them. This one, I made it a little bit better. It can color any point cloud or any raster with any image, PNG or RGB. So what you probably would like to do when you do serious work, to use something like this, right? To color your image, but for fun, because I said it's fun, you probably can create something like this. Here is Chris, and I used this picture to color this boring DEM, well, to make this beautiful picture on the right. So, and I have a few more examples. Just take any image, and it's available. You can do it yourself. So that's what we had at the beginning. That's probably what you want as your work, and then that's what you get just for yourself. Meanwhile, we have those results available, and I can try to, just explain them to you. So you can obviously see. So I can just click on a few values for you to see. Water, negative values, not very healthy. This urban area, around 0, right? So, and then this is a forested area, so much better. So, but it's not very clear. That's why I decided to coloring it. And you don't need that continuous range from -1 to 1. You can just have just a few ranges from -1 to 0, from 0 to 0.2, 0.4, 0.5. That's what I did here with the second image. And you can see again, water stands out really clearly. Then urban area, not very healthy environment for vegetation. Then here. So if you would download 3D data, DEM for that area and drape that, you would see that northern slopes are healthier than the southern slope. It's California, and that's probably obvious. Yeah, scorching sun, well, is not very probably good for southern slopes. So that's what you can get from just playing with infrared band. So if you go farther along that spectrum, you get to longer wavelength, and for example, snow and ice reflect those waves differently, not that intensely like with invisible range. So you can see more details there. So quite interesting for some analysis. I'm not a specialist. I just saw something and read something. And if you really need that, you probably can also find a lot of interesting things. So I hope I showed you how great FME is for playing with raster, how you can do a lot of interesting things with just playing with rasters by applying some math, by reordering them, by resampling, by combining, and doing some interesting operations. Just for fun, I will, because we have a few minutes, I will show you just a few things that I do with rasters. Sometimes it's just a bug in Data Inspector. That's not natural colors, but when you select it, it suddenly changes color. But when it looks nice, I save the screenshots. That's actually, I think, Mount Baker here. So it's over our mainland, lower mainland, yeah. Sometimes, you can create real art, something like this, right? So just a few images, raster mosaicer, and they average all the images together, and you get something like this. That's one of my sons. This is a normal raster, but I see a monster here. It's quality bit mask for Landsat over Georgia Strait. But sometimes I just see. This is an interesting one. And can you imagine, it is also a bug. It's Victoria, the capital of our province. I had some LiDAR data set, which I turned into raster and then made vector polygons and randomly set colors. And our random color setter does this. Is it random? Well, it's certainly random, but not quite, right? But again, when I see that, I file a bug and make a screenshot, just because it's beautiful. Yeah, well, yeah. And just recently, maybe 2 weeks ago, I made a workspace that does this, takes a normal picture and colors it randomly. I have no idea how I can use it, but maybe eventually I will find something interesting for that. I even made an animated GIF with that. I can show you, by the way. Again, with FME. Yeah, here it is. File is, of course, I experiment on myself because it would be cruel to experiment on someone else. Yeah. So maybe the last thing, because we still have probably a minute, I can show you this example, how you can, well, of course, you can just simply use any, downloader client to get to those Sentinel and Landsat data. But I just made an example how you can do that using FME, and you can download this example and make it for yourself. So here you just go and find any place on this planet, select the point, and then say what you would like to get, Landsat or Sentinel, and specify how much cloud coverage is enough for you. I don't know how cloudy this area is, but I can ask. Maybe Landsat probably is better. And submit. I hope to get something back. And it shouldn't take too long, about 30 seconds, I'd say. So something is running on FME Cloud right now, and I added some functionality there that makes it a little bit slower than it could be. I'm just drawing a small red circle. And if I wouldn't do that, that would be much, much, much faster. So here is cloud coverage. Here is date when it was taken, and you select what you like most. And you see brightness is very different, right? That's why you should work with each download maybe separately. So, and then you say, I would like this. Then you press this, and you are taken to, not to our website. It's Landsat on Amazon. It's their website, they maintain it, they upload that data, and you can download all those bands for you to use. And as you can see, it's all free. You don't have to pay anything for that. So I think this concludes my presentation. Thank you. If you have any questions, please ask.
Thank you so much, Dmitry. Any questions from anybody? No? When are you
Okay, I'm here till the end, so if you have any questions, yeah.
You should open an art gallery show. Should have a nice show.
Yes, yeah. My folder is called Art Gallery.
I haven't really used FME for raster processing, but I guess it removes the need for raster-specific software to do some of. Are you able to do kind of reclassification with training data?
Well, you probably can't do reclassifications because if you saw how I can do that with using some expressions to change from NDVI with continuous range to just some totally different raster, from real 64 go to integer values and have just a certain values. Of course, FME is not a real raster analysis processing tool. So we prepare data from the form it exists into the form that you need it in, right? Like with vector. Again, we don't do many vector things that GIS do, but we prepare your data. The same with rasters.
Great. Any other questions? No? Okay, we're off to get ice cream now, Dmitry.
Wonderful.
Very exciting. Thank you so much.